Good evening, everyone. My name is Takiwa Smith, founder and executive director of Science, Engineering, and Mathematics Link Incorporated, also known as SCM Link. And I want to welcome you to our Teen Science Cafe. The Teen Science Cafe is a program of our Math and Science Career Academy, whose goal is to engage students in hands on STEM activities and have them explore STEM careers. And the reason we choose to have this program targeted specifically for teens is because this is when teens start making decisions about what they want to be when they grow up and how to get there. For middle schoolers, it starts with, you know, out of school time program, what high schools they may want to go to if they're going to go to a magnet program, how they'll spend their summers. For high school students, it helps them determine when they'll major in, how they'll spend their summers, if they want to go to a magnet school, what classes they will take. All of these things at a critical time in youth educational experience where they're making decisions about what they want to be when they grow up. And the best way to learn what you want to be when you grow up is to learn about the different options that are out there. And that is why we have these teen science cafes to provide students with various options and have something personal where they can meet a STEM professional, learn about their journey, and learn a little more about their work. And so I am excited about this tonight's cafe for lots of reasons. First of all, I've known our speaker for a very long time, since early in my career. Secondly, I am a huge sci-fi fan. And so I do watch a lot of the Marvel stuff, but I love Black Panther because it shows Black people in their brilliance, Black people with scientists, all of those things. And as a chemical engineer, I love chemistry. And so I am so excited about this where we can show the connection between STEM and sci-fi, right? Because if you're a sci-fi fan like me, there are a lot of things in sci-fi that can be true, will be true one day, or you can say that can actually happen if somebody would create it. It's the possibilities. And so I am going to introduce our speaker, Dr. Collins. I'm going to read her bio briefly, and then I'm going to turn it over to her so we can talk about vibranium and the stem of Wakanda. So Dr. Collins has her earned her BA in chemistry from Wayne State University in 1994 and a PhD in organic chemistry from the Ohio State University in 2001. Dr. Collins served as the founder executive director of the Marburger STEM Center on the campus of Lawrence Technological University in 2016 to 2020. Beginning January 2023, she was appointed as the executive director of STEM education for the College of Arts and Sciences at Lawrence Tech. In 2008, she received the Real McCoy Award in Science from the Detroit Area Pre-College Engineering Program for her leadership and public engagement efforts in STEM education. Her research efforts include inorganic chemistry, chemical education, history of chemistry, and addressing inclusion and equity in the STEM fields. Dr. Collins is an active member of the American Chemical Society, serving as an associate member on the National Historic Chemical Landmark. I didn't even know this existed. Subcommittee. She is published in ACS journals, including Inorganic Chemistry, the Bulletin for the History of Chemistry, and the Journal of Chemical Education. Dr. Collins served as editor of the ACS Symposium Series, Volume 1381, entitled African American Chemist, Academia, Industry, and Social Entrepreneurship. She has authored a book chapter in the ACS Symposium Series, Volume 1370, entitled Inorganic Chemistry, Vibranium and Marvel Studios' Black Panther, and Critical Mass Takes Courage, Diversity in the Chemical Sciences, published in the ACS Symposium Series, Volume 1256. In 2020, Dr. Collins' career pathway was featured in Career Ladder Spotlight, published by Chemical Engineering News. So I am going to turn it over to Dr. Collins so we can learn about the chemistry of vibranium in Wakanda.
Thank you so much, Professor Smith, for the invitation. I'm delighted to be here this evening. It's good to see you. Good to be here to have a conversation about superhero chemistry in Wakanda. And I thought I would first begin by showing a movie clip first before we get started. So let me share my screen. And good evening to everyone that's watching. Only the most broken people can be great leaders. They don't call him General. They call him Kukulkan, the feather serpent god. Killing him will risk eternal war. He's coming for the surface world. We know what you whisper. We've lost the protector. Now is our time to strike. Show them who we are. So, what I would like is to know from all of you who are watching to share in the chat who is your favorite character in the Black Panther films and why.
So I have a favorite for each. So of course, for the first one, it was Shuri, because
Right.
Black women scientists, and then in the second one, it was Rihanna. Because it was just like not only was she good, but with both of them, they don't look at typical scientists, right? What the myths are,
Right.
and the fact that Rihanna created this like thing that people were like looking for her and didn't expect it to come from someone like her, right?
Right.
And just brilliant.
No, I agree. There's so many characters that I loved. Obviously, the late Chadwick Boseman, he was amazing as Black Panther. But Shuri is certainly my favorite because here she is, a young woman, just incredibly talented, and she's leading all of the research and development for an entire country, and it just goes to show you she's a shining example of what's possible, when everybody gets an opportunity, but then also I loved Queen Ramonda. Angela Bassett was amazing and she emotionally carried that film. But Shuri, Michael B. Jordan, I was, just amazing in those roles. So, do we have some comments here?
Yeah, someone said they just like the movie, they don't have a favorite character. And I can
Okay.
see that. Everyone was amazing in both movies, right?
Exactly, exactly. Everyone was amazing. No, and that's a great comment. It's hard to choose, right?
Mhm.
But these are both very great films. Okay, so let me begin showing my PowerPoint slides. So let me do that. Okay. Hopefully everyone can see that.
Yeah, we can see it. So once you put it on present mode, I'll be out. Okay.
Okay. So I'm delighted to be here, and we're just going to go through some of these, talking about superhero science chemistry. So I am a chemist, as Professor Smith mentioned, at Lawrence Technological University in Michigan. It's about 20 minutes from my hometown of Detroit, where I actually live. And I am currently an associate professor of chemistry at Lawrence Tech, also serving as executive director of STEM education. And what that means is I get the opportunity to engage with wonderful young people like yourselves and encouraging you to pursue a career in STEM. I actually believe everybody in the world should be a chemist, but I know that's not possible. But my whole goal is to make sure that you recognize that if you want a career in STEM, it's possible for you. So let's talk about some superhero science chemistry. So let me give you the backstory on how we ended up publishing this article, Black Panther, Vibranium, and a Periodic Table. We actually published this in June of 2018. And so, what I can honestly tell you, prior to this film coming out in 2018, I was not a fan of Marvel Comics. I did not read comic books, and I wasn't planning to see this film. But my little sister, Demetria, encouraged me to go see it. She kept saying, "You really need to see this film." So in February of 2018, I go to the movie theater with two of my younger cousins, and I'm enjoying the film. And it occurs to me that this fictional African nation is thriving on the production and use of this element called vibranium. And I could not stop thinking about that question, right? And that's kind of what scientists do. We come up with these questions that we think are interesting, and we want to solve them. And so, to make a long story short, after as I watched this film, I just could not stop thinking about where this fictional vibranium would be on the periodic table. So I go home that night. I start writing out what I think this paper should look like. I sent an email to my colleague, Professor Lavetta Appleby. I said, "Hey, have you seen this film? And can you ask this as a bonus question on your next exam?" And she did. And we found out immediately who the Marvel comic fans were in the department, used their responses to for the paper, and it was published. And that's kind of how I got into this superhero science research. So you never know where inspiration will come from. I just happened to be inspired when I went in the movie theater, and I ended up now on a new direction with superhero science research. Now, some of you may have seen these materials prior to um, this wonderful conversation that we're having tonight. And so I was interviewed but by a journalist from Scholastic Science World, which some of you may be familiar with this particular magazine because a lot of young people read Scholastic Science World. And so basically, it's a very short article, and I love the imagery um, that you see, the image of Black Panther and the periodic table. And so basically, they created this worksheet on classifying vibranium. So what I want to do is go through these particular questions with all of you today. So what we're going to do is classify vibranium. And so, what I want you to do, and I'm going to stop sharing my screen here. So, what I want you to do in the chat is I want you to tell me whether you think vibranium to be a liquid, solid, or a gas, based on what you know about the properties from the film. So, do you think it should be a liquid, solid, or a gas? That's the first question. Second is, do you think it has a shiny or dull appearance? Is it shiny or is it dull? Based on what you know from the films. Yeah, that's a great comment. We have someone that says they would guess it would be a solid. I agree. Do you think vibranium has a shiny or dull appearance? Yep. I agree also. It should be shiny. Absolutely. So this is great. Do you think it should conduct electricity? So that's another question. So we agree that it is shiny. We think it's a solid. We think it's shiny. I agree with that. Do you think it will conduct electricity? Another question. Do you think it's hard or soft? Based on what you know from the film. And the last question is, do you think vibranium is radioactive?
I
Anyone
mean,
want to share?
well, while we're waiting for the comments, okay, somebody said they don't see how it could, but it probably does conduct electricity.
That's a very good comment. And one of the reasons, you know, metals actually are very good conductors of electricity. Okay. And so that's one of the properties. So you are correct. It does. We would probably say that it would conduct electricity. Do you think it's radioactive? And there are some metals that are radioactive as well.
Do we interact with metals that are radioactive?
Yes, we do.
Okay.
We do.
Mm-hmm. So someone says it's a solid, but they think it's probably soft.
Because vibranium is, at least in the movie, is stored inside containers.
Mm-hmm.
You know what? It's possible that it could be, with metals, that's a great point. Because metals, one of the things about them is that they can be, we say they're malleable, right? So that means that we can put them in different shapes, So it's possible it could be between being hard and soft, So
Mm-hmm.
a lot of metals are hard, So But I think that's a very good point. And someone else said that they definitely think it's possibly radioactive. Yeah, that's a possibility too. I agree. And there are some metals on the periodic table at the bottom of the periodic table that are actually radioactive. So this is great. You guys are awesome. So let me share my screen again. Okay, so based on our conversation, this is fantastic. We think it's a solid. We think it's shiny. We probably think it conducts electricity. It could be hard or it could be soft. Metals tend to be hard, and it's possible that it's radioactive because in the film you kind of see it kind of glowing, um, kind of a beautiful purple color. And basically, what we have been talking about really are common properties of metals on the periodic table. And so, what I want to know from you is what do you know about the periodic table? Specifically, how is it organized? So, if you can share in the chat, what do you know about the periodic table? And how do you think it's organized? What have you learned so far from school? Anyone want to share? What have you learned about the periodic table? I think the periodic table is the greatest thing since sliced bread, actually. And it's the foundation of absolutely everything.
And typically, when do we like see periodic tables? Because I mean, I took chemistry in high school,
Mm-hmm.
but I don't think I remember. And people are putting someone put it together. I don't think I remember seeing it that much, in
And
before I
when
went
you,
to college and had to look at it all the time, right, and learn it.
yeah, we
Hmm.
have, so there are a couple of comments here in the chat.
Hmm. Hmm.
Someone said, let's see, AL Bynum.
Hmm.
I just put a puzzle together of the table over spring break. So just learning about it and all of its elements. I think that is
That
fantastic.
is fantastic.
And then we have the periodic table is full of rows and columns of chemical elements. Absolutely. You guys are on it. So let me show my screen again. And so you're absolutely right. So the periodic table, it's a wonderful organization of the chemical elements, and there are 118 chemical elements. And so the columns are basically, those are families, right? So the very first column, group one, that's considered a family called the alkali metals. The second column, which is orange, is the alkaline earth metals. And then you have in the middle of the periodic table, you have what's known as the inner transition metals. Okay, so all of those that are colored in this powder blue color. Then you have, let's see, the very last column that's purple. Those are known as the noble gases. And basically, the one next to it, that lighter blue, those are the halogens. And so, what's important about that is the columns of these elements, they have the same chemical properties, they behave very similarly. And then at the very bottom of the periodic table, you have two rows of elements, and many of those elements in that particular row are radioactive and they're man-made. Okay, but here's the thing. So this periodic table is organized by something known as an atomic number. Okay, and the atomic number is the number of protons in the nucleus. So what makes one element different from another? What makes one atom different from another? The number of protons in a specific in that nucleus. So a hydrogen atom has one proton in the nucleus, right? That's what makes it hydrogen. Helium has two protons in the nucleus. That's what makes it helium. Okay, so it's basically arranged by increasing atomic number. So now that we kind of have and I'm glad that some of you are learning about the periodic table, where do you think it would potentially fit if vibranium were a real element? Where do you think it would fit? You can share in the chat. And there is no right or wrong answer. You just have to back up your conclusions with evidence. Anybody want to take a guess? If vibranium were a real element, if it were a real element, where do you think it would fit? And then I'll tell you where I think it would fit as well. And I'm so excited to be here chatting with you wonderful young people.
Who wants to see the periodic table again so they can?
Let me share it one more time.
Yes.
We got a response here. Yep, I'm showing it. I'm going to show the chart again. I'm going to show it again for you. Okay, so I'm going to leave it up for a couple of minutes. And then you put in the chat where you think it'll be. So again, thinking about in the middle of the periodic table, that's where what we refer to as the inner transition metals. The bottom of the period, those two rows at the bottom, those are also metals, and many of those are radioactive. And that the last column, the purple column, so those are gases. Those are noble gases. And I just love the periodic table. I just think it's the coolest thing since sliced bread. Okay, I'm going to stop sharing. And again, there is no right or wrong answer. So what I'm seeing here is, yeah, there are a couple of responses saying probably in the middle section where most of the metals are located. Yeah, I would agree. I think that's a probably a logical place where if it were real, it would fit there. You could make an argument. Yeah, so we got another comment saying that it could be at the bottom because it's radioactive. Exactly. So again, there is no right or wrong answer. What's fun about this is you get to decide where you think this fictional element should be, based on the properties that you observed in the film. And I just think this is such a cool way to talk about the periodic table. You guys are awesome. Okay, let me share my screen again. And so typically when I do these workshops in person, the students, the wonderful students like yourselves, they work in teams and complete that worksheet that I shared to prepare a creative poster. And I think these are just some really awesome examples of posters that have been done by high school students and middle school students, where they work in teams and basically they're answering the question of where they think the fictional vibranium would fit. And what's really nice about this is they're always young people that are super talented, that love to draw and sketch. And so it's like bridging both science and art together, which makes it so fun. And once the posters are done, we put them on the wall for a gallery walk, just like you're in a museum, an art museum, and it is so fun. So this is something that you can do also. These are just really fun ways to learn about science. Now, having said that, I do want to briefly share my chemistry journey with all of you. And Professor Smith did mention my particular background. What I want to what I want to share with all of you is that I actually began my college career in community college, and I say that because everybody has their own path to success, and community college just happened to be my path. So your path is going to be different from someone else, right? Everybody's path is different. And I attended Highland Park Community College, which is now closed in Michigan. And I enrolled there because my mother, Nancy, was working as a secretary in the nursing department. So I was able to go to community college for free and earn my associate degree. So anytime you have the opportunity to earn a college degree for free, you take advantage of it. Okay. So while I was there, I enrolled in my first chemistry class, college level chemistry course, and I loved it. And so that's why I decided to be a chemist. Eventually, I went on and earned my undergraduate degree with honors in chemistry from Wayne State. Went on to the Ohio State University and earned my PhD in inorganic chemistry. So what that means is that I focus on really focus on transition metals, the middle of that periodic table that we talked about. And as a result of my education, it opened a lot of opportunities for me. I've worked at a African American History Museum here in Detroit. I've worked as a writer and an editor. I have been a college professor. So my point to all of you is that you can do so many different things over the course of your life. And so you're young enough now where I want you to think about this. Ask yourself, what kind of impact do you want to make in your community, in your neighborhood, and the world? And when you do that, that's going to help you figure out what your purpose is, what you want to do for the rest of your life. So asking those questions now, the answers you have now are going to be very different 5 years from now, and then 5 years after that. But I want you to start thinking about the questions now. And that's going to help you find your purpose and what you want to do for the rest of your life. And so, what I hope that you take away from this brief conversation, I'm just so glad to be here with all of you, is that I personally think chemistry is the best discipline ever. I think everybody should be a chemist. And the majority of the elements on the periodic table are metals, right? There are 118 elements on the periodic table. Metals have many applications. And so we often know that platinum and gold and silver, they're good for making jewelry. But those elements are also useful for curing diseases. For example, platinum metal is used in a cancer fighting drug called cisplatin. So it's useful for treating diseases. Gold has been used to treat arthritis as well. So there's so many more different applications for these particular elements. And so for the final thing that I want to mention today, which you can share in the chat, is I want you to share if you learned something new today. And what is it that you want to do with your career? And with that, I'll close and I'll be happy to answer any questions. And I'm just so thrilled to be here with all of you.
So while we're waiting on the questions in the chat, I wanted to know, like, what other chemistry, because we're focused on vibranium, and I know because
Mhm.
you're an organic chemist, but what are some other like chemistry that we saw in the movie that you may remember?
Yeah, actually, in the second film, if you noticed, and I'll, obviously this is a spoiler alert. Oh, so someone asked, can you repeat the second question, please? So basically, did you learn something new from this conversation? And also, what do you want to do for your career? What do you think you want to do? So those are the two questions. So in the in that second film, you notice that um, Shuri was using DNA kind of click chemistry, right? When she was trying to she was trying to come up with a synthetic version of uh, the vibranium herb, if you will.
Mhm.
And
Mhm.
that's something that we do as chemists all the time, trying to develop a synthetic procedure to make something that we need, right? And a
Mhm.
lot of times in science, right, you perform a lot of experiments and you fail a lot of experiments, right? But you learn from failure. And the whole idea is you got to keep trying, So the majority of the experiments that you do as a scientist are not going to work, but some of them will. And those are the ones that's what that helps you to keep going forward. So I think that that's really a key lesson from that second film. How she kept trying, and then finally she was able to achieve that. And that's exactly what happens in the laboratory when we're trying to make something, for the first time. We might not make it the first time, but if you keep trying and you basically, and it's not just repeating the same experiment, you're learning from what you did before to try to improve it. So I think those are the key takeaways.
Mhm.
Some other types of chemistry that you see in the film.
Mhm.
Okay, so
Okay.
one person said, "I did learn something new: how the periodic table was broken up and what the numbers made. I love science and math, and I would like to be an engineer." I love that.
Mhm.
Love it. Yes, engineers are awesome people too.
Yes, they are. I could be biased.
Okay.
Uh,
Someone says I don't really have an idea for a career. That's okay. You're
mhm.
young enough and you can start thinking about what what gets you excited, right? What gets you out of bed? What is it that you really, really love? And if you're doing something and you love it and you can't, and you would do it for free, because you're just that passionate about it, that's what you should be doing.
Yeah, or think of things that you're really good at and
That's
what
right.
interests you, or even sometimes you need a little help, right?
Right.
Because I have my degree in chemical engineering, and some classes are just hard,
Right.
but I didn't give up. I got a tutor, I asked classmates. So sometimes you just need a little help because there's no way you can know everything, right?
Right.
Like, mhm.
Asking for help is a sign of strength, not a sign of weakness. If you don't know something or you can't figure it out, ask your teacher. That's what you do. You ask for help. Um, the other, the other piece of that too is I want you to also realize is that you can do more than one thing,
Mhm.
with your career. Don't think if you get a degree in engineering that all you're going to do, that's what you're going to do for the rest of your life. It may be, and that's fine. But for example, I know someone who's just a wonderful young man, has a degree in physics, and went to film school, earned his Master of Fine Arts, and now he's a filmmaker. And I just think that is so brilliant to use your science background and also using that to tell stories. So that's something that you can also think about as well. So just, it's really an exciting time to be to pursue, I think, a career in STEM or science, because there's just so many different things that you can do. And so, as a result of my passion for history of science and telling stories about the important contributions of women and people of color in these fields, I publish all of these articles. I now collaborate with students who are majoring in media communications to take some of my work, and actually they've created two narrative films celebrating women in science. So that's kind of what I'm doing now. I'm diving into filmmaking a little bit. So even though I have a doctorate in chemistry, and yes, I can go in the lab and blow stuff up, and there's fun in doing that. Um, I get a chance. I'm doing something else with my degree, and it all goes back. The training that you receive, those skills, being able to work in teams and collaborating with people, all of that is transferable. So that just means that the skills that you learn in one area you can use it in other places. So yeah, so just remember, what I had shared. Ask yourself, what kind of impact do you want to make in the world? What kind of impact do you want to make in your neighborhood, in your community? That's going to help you figure out what you want to do for the rest of your life. And I'm still trying to figure that out.
And also a shameless plug, if you are watching us on YouTube and you're trying to figure it out, we have so many um, different STEM professionals that have been speakers at our virtual cafes, and you could just watch it and figure out. Like we've had architects, we've had an engineer that works on roller coasters, we've had somebody that studies disease with zebrafish, and so the great thing about you all growing up when you have grown up is the resources that are available to you on the internet to do some research about things that you may be interested in to figure out those career paths that you can pursue.
Absolutely. Absolutely. Any other comments or questions? So I'm just so thrilled to be here with all of you talking about Black Panther. And I hope, uh, the connections to the periodic table maybe sparks your interest a little bit more in chemistry. And I want you to start thinking about, again, what Professor Smith said, identify what you're really good at, and what you enjoy. So that's going to help you figure out what you want to do.
Mm-hmm.
And
And
don't think of you.
also,
Go ahead. Go ahead.
I was saying also it can be multiple things, like because of the disciplines that are created. If you like to program and you like biology or chemistry, you can do computational chemistry.
Right.
If you like forensic science and art, if you like architecture. So it can be multiple things. The beauty of STEM and it being interdisciplinary is
Right.
that you can choose something that a career that fuses two or more of your interests.
Right. And that's what I've been able to do. I love writing and editing. And I know a lot of people don't necessarily like to write essays and papers and that sort of thing. I love to do that kind of stuff, particularly if it focuses on history of science and I learn about an unknown hidden figure, if you will, so I'm really passionate about telling those stories.
Yeah, if there's no questions, I just want to ask your parting words about um, what advice would you give to, wait, well, a multiple, let me come back. When we think about sci-fi and,
Right.
and making that connection to the STEM and sci-fi, how do we make those connections from what we read to know like what is possible or what can we just imagine through reading this sci-fi, because it's sci-fi and it's science, right?
Right.
And
Right.
mhm,
Yeah, so for me, I that's a great question. And it's taken me, I'm what I always do, because I can't shut off my chemistry brain, I'm always looking for some connections. So whether I'm watching a television show, a movie, um, listening to a podcast or something that I read, I just, I'm able to try to see what those connections are. And the point is, inspiration can come from anywhere, right? And so, also recognizing, and I do try to stay up on pop culture a little bit. Most of the time, I don't know half of the references, but, it's, and even like one of the things about the films, though, that I think is important is that a lot of the science sometimes that's in there is not correct. Okay, it's not correct. But what's beautiful about that, it allows us to have a conversation about, okay, this concept was seen in this film or television show. Let's talk about the real science, what really happens in the classroom. And I think that's a natural way for educators and also students. For the young people who are watching, think about your favorite television shows or movies and see if there's some really cool science or technology that's exhibited in those particular genres, if you will. And I read it would be really cool if you were able to do that and talk to your teachers at school. Say, hey, I watched this television show and I saw this. Can we and relate it back to something that you learned in class? I think that's a cool way to make those connections.
I also, and I'm probably dating myself, I think about like Jetsons and the
Yeah,
whole Star Trek and stuff that was in that cartoon. And
right,
you're like, oh, that exists today. And
right.
I wonder, I guess how they say art imitates life.
Yeah,
And I wonder what scientists saw that like, that was cool. I need to make that happen.
right. Yeah, and no, you're right. The Jetsons really, they were working from home. They were doing
Mhm.
Zoom, you know, long before we were doing it. And here we are, in this particular, uh, in our current society. But the last thing that I want to say to young people
Mhm.
is just some parting words, because I already mentioned I want you to think about your why, right? What gets you up in the morning? What gets you excited? What are you good at? I also want you to recognize that your happiness is your responsibility, right? It's not the responsibility of your parents or your friends. Happiness starts with you, right? And so that's one of the a key parting word that I want to leave with you. So figure out what your why is. What do you want to do for the rest of your life? And it's going to change. But understand that your happiness is your responsibility.
That is so great. And I am just happy. I got a whole bunch of like sci-fi books I need to read. And I'm like, I'm about to catch up and finish them. But thank you so much because I do think that we need these reminders that STEM is everywhere, right?
Right,
And how even things that are quote unquote meant to entertain us
right.
can make us think about STEM and think about things that we're interested in, think about possibly things that we could do in our career.
Right. I mean, think about, you're right, STEM shapes our everyday experiences. Think about 3D printing. The automotive industry, they use 3D printing like to create some pieces for an automobile. For example, maybe some of the cup holders in the car, those could be 3D printed. So if you think about anytime you start a car, batteries, that's chemistry right there. You think about hair care products, that's chemistry, that's science. So it impacts everything that we do. These cell phones and laptop computers, those are STEM products, right? That's those things, that technology, all of that is due to STEM.
Well, thank you so much, Dr. Collins. And thank you so much for everybody that has joined us either live or you're catching the replay because you have visited our YouTube channel. And I think I want to watch both Black Panthers. They're on Disney Plus now this weekend and just get a refresher. Maybe
All
I'm
right.
folding clothes. All
Well,
right.
thank you
Well, thank
so
you,
much.
everyone. All right. Have a good evening.
Okay, bye bye.